This video is on residuals. If a linear model is appropriate for the data, then the residual plot will be evenly scattered or dispersed. So if we look at our residual plot as a horizontal aspect, the residual plots, instead of just on the linear regression, our data points will not really make a pattern with the values. They will be evenly dispersed. They're not going to make any type of picture. So if we look at this example down here to find the residuals and the predicted values and to look at our residual plot, we can see on here that we have data points and we have a line that we've put as a best fit, but you can see that these data points are much too far away from our line to seem to be fitting very well. Now we've done a linear regression on these data points of 2, 5, 4, 15, 6, 25, 8, 23, 10, 11, and 12, 3, and we've gotten the equation y equals 0.343x plus 16.067. So we have the original coordinates, which is where the data points are, and so we want to find the residuals. The predicted value is by plugging in the x values into our regression equation. This gives us our predicted values. So again, we're going to use x. So our predicted values for plugging in 2 into our regression equation is going to be 15.381. When we plug in the 4, we're going to get 14.696. Plugging in the 6, we're going to get 14 and 1/100. Plugging in the 8, we're going to get 13.324. Plugging in the 10, we're going to get 12.638. And plugging in the 12, we're going to get 11.952. These are the predicted values. So we were supposed to get 23 at the 8, but instead we only got 13. Same with when we plugged in the 6. We were supposed to get 25, but we got 14.01. So these values are much different than what the observed value is. So if we look at the residuals, we're going to take the actual value and subtract the predicted, because we want to see how much is left over, how much space is left between the two values. So we're going to subtract these numbers to get the actual residual. So when we take 5 minus 15.381, we get negative 10.381. 15 minus 14.696 is equal to 0.304. So that residual is very close because it's almost on the line. This residual is negative because our data point was below the regression equation. On our next one, 25 minus 14.01 is 10 and 99/100. The next one of 23 minus 13.324 is 9.676. The next one is supposed to be 11 minus 12.638 is negative 1.638. And then the last one of 3 minus the 11.952 is negative 8.954. Now if we look at our residual values, we can see that our residual values are very, very far away from 0 except for 1. Now this is different than in the last example where our residual values were very close to 0, meaning that the regression equation for linear regression fit this data very well. This time, our residuals are much further away from 0, and we can see that our regression line does not fit the data very well. So that means that linear equation would not be the best model to use. Instead, we might want to use an exponential or a quadratic regression to help us find the correct equation to fit this data. So if we were to plot our residuals, we're going to look at our scale that we'll need to use for our x's, and then we will look at our new residuals so we know what to put on our y's. So we want to make sure we go up to 12, so I can count by 2's on the x-axis, 2, 4, 6, 8, 10, and I'll add a little bit more here to 12. And then we need to go down to at least negative 10.381. So what I'll do is I'll count by 2's on the y-axis as well. So 0, 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, and negative 10. Now I'll go and plot the residuals. So at 2, we'll go to negative 10 and 0.381. So a little bit underneath the negative 10. Then we'll go to 4 is at 0.304, so a little bit above 4. Or a little bit above 0, I apologize. At 6, we're going to go to 10 and 9900, so almost to 11. So about halfway up from there. At 8, we'll be at 9.676, so a little bit underneath the 10. At 10, we'll be at negative 1.683. So about right there. And at 12, it's at negative 8.954, so almost at negative 9. So about right there. So our residuals, if we look at our residuals, it's not evenly scattered. It's almost making a pattern within our data points that look like this, because our line is almost horizontal itself. So again, if we were to take this picture and make this line actually horizontal, we would see the pattern almost the exact same because our regression line was almost horizontal already. Since it's not evenly scattered or dispersed, this linear pattern, this linear equation would not be the best. So if a linear model is not appropriate for the data, the residual plot will actually more make a curve or a pattern. It'll make a curve or a pattern. And this one absolutely does curve. It goes up and then back down. It's not evenly dispersed. So we might see something that looks like this. They're not evenly dispersed. They make a curve there. Or we'll see almost like this one up here, where they are going this way. Again, not evenly dispersed. So residuals are the space between the original data points and the regression equation that we have used. Linear will not always work. If the residuals are far away from 0, then that regression equation will not be the best fit.